All right, number 4 is the limit as n approaches infinity of 1 over n. What does that equal? 0. So does it diverge?
No. We don't know.
We don't know. And the big question is, maybe. But we don't know. So in this situation, when the limit of the nth term equals 0, your series may converge or it may diverge, and the rest of this chapter involves other tests that we're going to use. So that's why we always want to start with the nth term test, because if the nth term does not approach 0, we can immediately say, okay, it diverges, I can move on. But if it approaches 0, we're going to have to do more. For example, the sum of 1 over n actually diverges, but 1 over n squared happens to converge. And we'll talk more tomorrow about why that is. But it kind of boils down to not only does the nth term need to approach 0, but convergence is dependent upon how fast that nth term is approaching 0. So if you have 1 over n and 1 over n squared, which one's going to approach 0 or get smaller faster? 1 over n squared. So it's doing it fast enough to converge, whereas 1 over n actually isn't getting there fast enough to converge, and it diverges. Okay, geometric series. You actually learned about this last year. An example of a geometric series is 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4, etc. And what's significant about a geometric series is that a geometric series has a common ratio. And that common ratio is called R. And the way that you find the common ratio is that you take a term, we'll call it a sub n, and we divide it by the term in front of it. We'll call that a sub n minus 1. So like if n is 3, then a sub n minus 1 would be a sub what? 2. Okay, so the third term divided by the second term, or the 10th term divided by the 9th term. And no matter, in a geometric series, no matter what term you pick, as long as you divide it by the 1 in front of it, you're always going to get the same number. So 4 divided by 8 is 1/2. 2 divided by 4 is 1/2. 1 divided by 2 is 1/2. So in this particular case, your common ratio equals 1/2. So a geometric series with a common ratio of R will diverge if the absolute value of R is greater than or equal to 1, and it will converge if the absolute value of R is between 0 and 1. And if it converges, this is one of the few series that it's easy to find the actual sum, and the sum of that series is A over 1 minus R. However, you need to think of A as the first term. We'll come back to that in just a second, but that A is the first term of your series. All right, geometric series are easy to spot because they're always in a very similar form, and that form is that you're taking a number and it's being raised to a variable power. Now, it may be just to the n power, it may just be to the n plus 1 or n minus 1 power, but it's some number raised to a variable power, and that's how you spot a geometric series. However, you could always test it to see if it is geometric by plugging in some numbers. Like if you plug in a 1, you're going to get 6 times 1/2 to the 0, so just 6. If you plug in a 2, you would get, for n, you would get 6 times 1/2 is 3. If you plug in a 3, you're going to get 6 times 1/4, which is 3/2. So are you all convinced that this is geometric? Okay. So what is R? Right, 1/2. And R is always that number that's being raised to the variable power. So R is easy to spot without having to plug in numbers to get those actual terms of your sequence. All right, so according to this box up here, does the series converge or diverge? It converges. Good. Because R is less than 1. So that's the reason it converges. Let's actually find the sum of the series. Okay, so the sum of the series, I use this formula right here. what is your first term of this series? 6. And you get the first term by plugging this bottom number of n into your equation. Sometimes the series start with n equal 1. Sometimes they start with n equals 0. So whatever that number is, that's what you plug in to get your first term. All right, so your first term is 6. The formula is divided by 1 minus r, so 1 minus 1/2, which is 6 divided by 1/2, which equals what? 12. So if I add up that infinite number of terms, 6 plus 3 plus 3/2 plus 3/4 plus 3/8, etc., I would end up with 12 at the end. Okay, sometimes they're written very nicely, like number 4. Sometimes they're not written quite as nicely, but I still have a number that's raised to a variable power. How can I make number 5 look a little bit more like number 4? Okay, I could do one of two things. I can bring the n plus 2 up to the top, the 4 to the n plus 2 up to the top, but it would be 4 to the negative quantity n plus 2. I'm not really crazy about that negative exponent, but I heard somebody else say rewrite 4 on the bottom as 1/4 to the n plus 2. Because 1 to the n plus 2 is still just going to be 1, and then 4 to the n plus 2 is still down there on the bottom. Okay, so what is r? 1/4. And that's why I don't want you to use those negative exponents, is because then it's easier to identify what r is. So r is 1/4, so does the series converge or diverge? Converges, because r is less than 1. And then to find my sum, I'm going to use this formula right here. What is the first term of this formula, or of this series? It'd be 8 over 4 to the what power? Yeah, let's just keep it at that for the time being. So I'm plugging in a 1 for n, so I get 1/4 to the third times 8. All right, and then divided by 1 minus r. 1 minus r will be 3/4. So 8 over 4 cubed times 4/3. And that's easier to deal with because the 4 on top will give just 4 squared on the bottom. So 8 over 16 is 1/2 times 3 is 1/6. Okay, the last geometric series. 3 to the n. It's geometric because I've got a number that's raised to a variable power. What's my r? 3, right? So does the series converge or diverge? Good. And if it diverges, I can't find the sum because the sum would be infinity. So I'm done. All right, I was being kind of goofy here, but geometric series are our friends because they are fairly simple. They're fairly easy to recognize, and once you recognize it's geometric, if you can identify what your r is, you know if it converges or diverges by whether or not r is greater than or less than 1. Okay, the last type of series that we're going to talk about today is a telescoping series. And this is just kind of an interesting series. The question says, does this series converge, and if so, to what? I'm just going to start writing out some of the terms of this series. So I would start with n equals 1, because that's what's down here on the bottom of my summation. So if I plug in a 1 for n, what would I get? 1 minus 1/2. Good. All right, and if I plug in a 2 for n, then I'm going to get 1/2 minus 1/3. And a 3 for n, 1/3 minus 1/4. Hopefully you're beginning to see a pattern. dot, 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 till I get to 1 over n minus 1 over n plus 1. So I could find this sum by adding up all of those terms right there, which in a lot of series would be very tedious to add up a whole lot of terms. However, could you fairly easily add up these terms? Yes. Why? Yeah, 1/2 minus 1/2 cancel. And then I have negative 1/3, but plus 1/3. So that cancels. Negative 1/4 plus 1/4 cancels. Negative 1/5 would cancel with the next term, which is going to be positive 1/5. So what part, if any, of the 1 over n minus 1 over n plus 1 will cancel? Right, that 1 over n will cancel with whatever's in front of it. So this whole sum ends up just being 1 minus 1 over n plus 1. And as n approaches infinity, what will 1 over n plus 1 approach? 0. You'll get 1 divided by infinity, which is 0. So that entire, that entire sum ends up just being 1. So because 1 is the actual sum, since it's considered to converge, because that sum is a specific number. So, all right, now telescoping series are actually not on the AP exam, so this is the last that you're going to see of the telescoping series, but I think it's just kind of an interesting one, and I wanted to throw it in there. So you will not be tested on it, and it's not going to be on the AP exam. All right, and then at the bottom of this worksheet, and I could hear that some of y'all were already trying to kind of work through this, but I just kind of like puzzles like this, and so I thought that I would throw this out there. So these are sequences. There's some sort of pattern to those letters in number 1 and numbers in number 2, and I just put them on there in case you're the type that kind of likes to figure those things out. So I will tell you tomorrow what the sequence is.